Here are instructions for the lab on motions of the Earth-Moon system. We're going to be drawing a lot of pictures, so you should get out your colored pens and pencils and some paper. Start out with a picture of the sun, partly on the page like I've shown here, and a picture of the Earth. We're going to be looking down on the North Pole as shown here. We're going to draw the circle of illumination, which we talked about when we talked about the seasons, and that's basically the shadow line that divides night and day as produced by the sun's rays. I'm going to shade the side that's night to emphasize where the shadow of illumination is dividing night and day, right here. Now I'm going to put a student on my Earth, and this student is at the position of Earth where she has a lot of sunshine directly coming from over her head. So what time of day is it for my student? Well, it's noon, essentially. I have another student over here, and he has his little sleeping cap on. I don't know why people used to wear sleeping caps. Maybe their heads were cold or something. But for him, it's essentially midnight, right? It's in the middle of the night. Keep in mind that these students are rotating around the Earth, around this North Pole axis. Now what about this student right here? Well, for this student, it's either going to be sunrise or sunset. It depends which way the Earth is rotating. Is it rotating that way or this way? Well, it turns out that if you look down on the Earth's North Pole, it's rotating in a counterclockwise sense. So for this student, it is essentially sunrise. They are spinning from night to day. So that person is experiencing sunrise or 6 a.m. The person over here is spinning from the sunlit side of the Earth to dark. And so for them, it's sunset, or for simplicity, we're going to say 6 p.m. So I want to make sure you understand these parts of the Earth-Sun system and the times before we add the moon. One thing I want to emphasize is that you shouldn't just memorize that noon is to the left and midnight is to the right, because in this case I have the sun to the left, but the sun could be anywhere. Here I have the sun in the upper right and the Earth looking down on the North Pole on a diagonal towards the lower left. The sun's rays are coming this way, and so the shadow of illumination would be in this orientation perpendicular to the sun's rays, and that would be the night sky. So in this example, noon would be where the direct sunlight is hitting. Midnight would be the other side of the Earth. And because we're still looking down on the North Pole, we still have counterclockwise motion. So sunset is going to be over here, and sunrise is going to be over here. So rather than memorizing, just think logically about where things are as people are spinning on the Earth. Imagine that's you right there, and you're spinning. As you go away from the sunlit side, it's sunset. As you come into the sunlit side, it's sunrise. So back to a new figure where we're going to start in a similar sense. We've got our sun and our Earth again, but now we're going to add the moon. And this is a picture of the moon. I've placed it between the Earth and the sun. Now none of this is to scale. This is a much bigger moon and Earth compared to the size of the sun, and everything is much closer together than in reality. In fact, here's an actual scale model showing the sun and the Earth moon and the approximate true distance if you were going to try to scale everything. So I can't do that on the slide. It wouldn't make sense. I wouldn't be able to show you the detail I want to show you. So keep that in mind. Now on your paper, I want you to draw more than one moon. Of course, we only have one moon, but I want to show it in a bunch of different positions. So you've got this one drawn, I hope, between the Earth and the sun. And then I want you to draw another one on the other side of the Earth. I want you to draw a third one above the Earth and a fourth one down here below. So you've got 4 moons. And pause the video when you need to. We're then going to draw 4 more moons in between each of those, like this. And it's okay if they're not equally spaced. I want to give each of these positions a number just so it's convenient as we talk about them. I'm going to call the first one we drew number 1, and then I want to number them in the order that the moon moves around the Earth. And it turns out that the moon, looking down on the Earth's North Pole, also moves in a counterclockwise sense. So let's number them in that sense, all the way up to number 8. Next, I want to draw the circle of illumination on all of these moons. And because the Moon-Earth system is so far away from the sun, the circle of illumination is going to be parallel to the circle of illumination on the Earth. So all of these are going to have a vertical line on the page. I've tried to do it vertical, just like the one on the Earth. So go ahead and shade the side of the moon that is not receiving sunlight for all of your moons. Now we're going to think about what this looks like from Earth for each of these positions. Well, if you're on Earth looking up at the moon when it's in position 1, what are you going to see? This red line indicates that you're going to see this half of the moon, right? You can't see through the moon to the other side. And what you're going to see is basically nothing because it's dark. And this is what we call the new moon. So you're going to have a chart that you're going to put together, and so you want to put this on another page. So this is position 1, and the appearance from Earth is nothing. So I just kind of put a dashed circle to indicate there's nothing there, but it is there, we just don't see it. And this would be the new moon phase. In a couple days, the moon will have moved to position 2, and now something interesting happens. From our perspective on Earth, we'll see that actually a little portion of the moon is illuminated. From our perspective, it looks like the right side of the moon. It's not a lot of the moon, it's just a small portion. From our perspective, it will look like a crescent on the right side of the moon. And that is a waxing crescent. Position 3 is shown here. And it looks like we're looking from upside down, but remember, everything is relative to the Earth. When we look up, we'll see that the right half of the moon is illuminated. And now we have our first quarter moon. So we've had a transition from new to waxing crescent to first quarter. And I bet you can guess what's coming next. The waxing gibbous. Now, a large portion of the right side of the moon is illuminated, but it's not quite full. And that's the waxing gibbous. When we get to position 5, we now see the full moon. The entire portion that we can see from Earth is full. What happens next? Well, now we go to the waning portion of the lunar cycle. We are now in another gibbous phase, but this time the gibbous is on the left and the dark portion is on the right. We have illuminated portions mostly on the left, a waning gibbous. Phase 7 is illuminated half on the left and dark half on the right. That would be our third quarter or last quarter moon. And finally, phase 8 is a crescent on the left side. And that's the waning crescent. So all of these different phases that you've seen while you were doing your observations are a matter of the position of your view, your perspective from Earth. In your lab, you've got a picture similar to this on page 186. Notice that the sun is on the right, not on the left the way I drew it, just to challenge your spatial thinking a bit. If you're really challenged, you can turn this page upside down and compare it to what we just drew. The first question is asking you to draw a line through the moon that separates the half of the moon that's facing Earth from the half that can't be seen. These are like these red lines that I drew here. So I drew a few of them for you. There's one on the first quarter moon, the waxing crescent, the waning crescent. That's enough. I think you get the idea. Then it asks you to darken with a pencil the part that we can't see. And so I just did a few of these with a red pencil, and I just did 2. I think you get the idea. The next 2 questions ask you about the various positions around here. I think you can answer them. And then question 5 asks you to match the position numbers, like position 3, position 4, with the picture of what it would look like from Earth. So this is pretty similar to what we just drew. Now the pictures are a little more realistic, and you're going to list them here with the name of the phase. So that's the first part of your lab. The next part has to do with how long are these different phases up in the sky? Let's start with the full moon phase over here. Now, you could be anywhere on this half of the Earth and see the full moon. If you were over here, you can't see the full moon because you can't look through the Earth and see this side of the sky. Let's not pretend we're on the North Pole. That would make it difficult. So here's a student from earlier, and She cannot look through the earth and see the full moon. Now remember, her eyes aren't really this high in the sky. She's down here. She can't look through. Even here, she can't see that moon. But right at this point, right at dusk, she can see the full moon. And for her, that full moon looks like it's on the horizon. It looks like it's just rising in the sky. As she continues through the night, the full moon appears to rise higher and higher until around midnight it's directly overhead. As she continues through the night, the moon seems to drop down in the west, and then finally it sets as she spins into the daylight. And then once she's back in full daylight, she can no longer see the full moon. It's still there, right? She can't see it though. So the full moon rises at sunset and sets at sunrise. It's up for about 12 hours. Let's try this one. This is the third quarter. This person here sees the third quarter above their head at sunrise. As they start to spin with the earth, remember they're spinning with the earth, this third quarter moon looks like it's getting lower and lower in the sky until they get to noon, and now it looks like the third quarter has set. Once it's past noon, they can now look through the earth and see the third quarter. So the third quarter moon rises at midnight and sets at noon. So every phase has about 12 hours in the sky. And hopefully you got that question right on your moon project. Let's do one more. This one's kind of tricky. This is a crescent phase. So how do we know when that one rises and sets? Well, for any phase at all, you just sort of take this line, which is perpendicular to the line of sight between the two bodies, and that's the 12-hour time period during which you could see the moon. So if this is 6 a.m. and this is noon, we could call that 9 a.m. and we could call that 9 p.m. So this waxing crescent phase here rises around 9 a.m. and sets around 9 p.m. So if you told me during your observations, for example, that you saw a waxing crescent at 3 in the morning, I know that's simply not possible. Similarly, if you told me you saw a third quarter moon at sunset, I know that that is simply not possible. The questions associated with this are Activity 1B, and I'm not going to go through all of them, but they basically ask you to look at that diagram on the previous page and try to understand when various phases set and rise and when they're not visible. Next, we'll move on to rotation and revolution in your next video.